In this video, we will look at how to generate wrapping patterns on a grid in Mobius. We will look at creating 3 tubes: a tube of quads, a tube of horizontal hexagons, and a tube of vertical hexagons. Note that the tube of quads can more easily be generated using the make.extrude function. The way we do it in this example is in order to demonstrate a technique. For all 3 tubes, the positions are created using the same user-defined function. The function creates a nested list of positions. Each sublist is one ring of positions. The rings are stacked to create a tube. The function has width and depth parameters. The width parameter is the number of positions in each ring. The depth parameter is the number of rings. We can print the list of positions to check its structure in the console. We can see a list with 6 sublists. Each sublist has 10 positions. So in this case the width is 10 and the depth is 6. The first sublist is the bottom ring, and the last sublist is the top ring. Each node in the flowchart has 3 user-defined functions. The first function creates the tube of position. This function is the same for all 3 nodes. The second function creates a single polygon. In this case, it is a quad. The third function fills the tube with the polygons. It repeatedly calls the second function. For quads, the main procedure calls the local.fillQuads function one time. This creates the tube. For the horizontal hexagons, we see similar functions are being used. The first function is the same. It creates the tube of position. The second function creates one horizontal hexagon. The third function fills the tube with hexagons. In this case, we need to create 2 patterns that interlock. So the main procedure calls the local.fillHorizontalHexagons function 2 times. The vertical hexagons is the same as the horizontal hexagons, except that the function implementations will be slightly different. Let's have a look at the function implementations to see how they differ. We have 3 different functions for creating polygons: a quad with 4 positions, and 2 types of hexagons, each with 6 positions. In each case, the function is given the coordinates of the bottom left corner in the grid of positions. These coordinates are the variables I and j. The variable I selects the ring, and variable j selects the position in the ring. Based on the coordinates of the bottom left corner, the function extracts the positions required for making the polygon. Positions are extracted out of the nested list using 2 indexes. The second index needs to be wrapped, so that the polygons will form a closed tube. Notice the use of the modulus operator and the width variable to implement wrapping. We have 3 different functions for filling the tube with polygons. Each function has 2 nested loops. The outer loops iterates over the list of rings. This loop creates the variable I dot. The inner loop iterates over the positions in each ring. This loop creates the variable j. The loops are used to define the bottom left corner of each polygon. To create the polygon, it then calls the previous user-defined function. In each of the 3 cases, the polygons have different shapes. So the spacing between the bottom left corner of consecutive polygons will differ. This change in spacing is handled by the range function. Note how the arguments to the range functions differ in each case. Finally, note that the grid of positions can have any shape in 3D space. In this examples, positions define a more complex type of shape. As long as the structure of the nested list is the same, exactly the same logic can be applied.